Is it good now? Okay. I don't know, some problem with my microphone. I'm sorry about that. Okay, so what I was saying is, yes, I'll repeat. So let's get rid of this. First, I've created an object, say person object, with some properties, such as its name and say here's age property as well. This is a simple object, and I'm creating this using object literals in JavaScript. Even though there are quite a few ways that you can create an object, we have seen few of them in Node.js. Okay. So if I try to assign age, I can do it. I can access a property, I can assign it. This is well and good, and it makes sense. And surprisingly, I can even assign a string value to age, and there are no complaints from JavaScript compiler. I can execute this line of code. Still, JavaScript won't complain. And when I say console.log person, it outputs age as ABC, which doesn't make much sense in real world, but JavaScript takes it because it is dynamically typed language and it doesn't really care what type of data that you are trying to assign. Doesn't really bother because in JavaScript object like variables are like containers. You can put pretty much any type of data, and that can create a lot of problems in future when you're working with enterprise level applications. You are seeing runtime errors, not the compile time errors, because of type mismatch. What I mean is, let's go ahead. I'll say mobile.call. I don't have a mobile object created anywhere here, but I'm trying to call a function on top of that object. There are no compile time errors at this moment. I'll go ahead and run this file. See, I'm getting a runtime error, and runtime errors are costly to fix. And most of the errors you see in your application because of type mismatch or the variables which are not defined or something like that. And these type of bugs are pretty much like predominantly more in your application when you're working with JavaScript. And as a developer, you feel like your code is fragile because you don't know where and what are the things that going to break. Because unless you run the program, you won't know what's wrong with your program. And when you run the program, that is when it is called a runtime error. And that runtime error may make it its way to production. And production bugs are even more costlier to fix. So, what's the solution for this? It doesn't mean that dynamically typed languages have no benefits. It's not true. They have their own benefits. Like with very little amount of code, you can do a lot of things. And that's their advantage. Again, they have their downside. This is the downside. So, you're trying to set some meaningless value to a variable. You're trying to call something which doesn't exist. So the solution for this is TypeScript. TypeScript is a project started by Microsoft. It added types to JavaScript. The reason why it is accepting ABC for age is because it doesn't know what type of data age can hold. That's what the issue is, not having types. If you have a type, probably JavaScript would have given an error saying that, okay, this is of type number, but you're trying to assign a string. So the solution is TypeScript. We'll talk more about TypeScript in today's session. Let's change this file to TS. And with that one change, now you'll have some feedback from the compiler. It's giving you an error. It says, cannot find name mobile, which means it doesn't exist in this context. You're trying to call something which doesn't exist. And here, if you notice here, you cannot assign ABC to a number. So it identified with your assignment that age is a number. And when you try to override the value with a string, it's giving an error. So believe me, this is very, very helpful for a developer because most of your errors are found at compile time itself. Compile time means you're when at the time of your when you're writing your code, You cannot build this application because there is a compile time error. When most of your errors are found at compile time itself, definitely your code would not be fragile. You would be more confident about your code, and that's when TypeScript comes into picture. So we'll write our code in TypeScript, and then we'll convert it into JavaScript. Why do we need to convert it into JavaScript? We'll talk about that. But this is what TypeScript is. In one word, TypeScript is called a superset of JavaScript. So you may know sets, subsets, and superset. Set is, say you have some elements inside set. What is subset of this set can be 1, 2, 3, 1, something like that. Subset having few elements from the parent set or some set. Superset is something you'll have all the elements from this set, more than, apart from that you'll have few more. That's what superset means. So if you have understood what this means is, you should have already understood what is TypeScript means. TypeScript is a superset of JavaScript, which means it has all the features of JavaScript. Apart from that, it has few more features such as types. We'll talk about them. So this tells you that any JavaScript file is a valid TypeScript file because of this concept. Okay, so now you might have understood why TypeScript is important, and that's why Angular itself is written in TypeScript. Google team has written Angular in TypeScript, and we will also be doing the same thing. We'll write our code in TypeScript when writing Angular application. It's a good idea to learn TypeScript. Again, it's not going to take a lot of time because if you have knowledge of C# or Java, that's going to help you a lot because you'll feel like home when if you have knowledge of Java or C# because pretty much the syntax remain similar for the most part. Okay, let's go ahead and try to see how can you be more explicit about the type of the data that you're going to save. For instance, I'll say x colon number 20. Here is here is an explicit way of saying that okay, I'm declaring a variable x whose type is going to be number. And if you try to assign something to a x, you'll have an error. Okay, let's remove this like this. Now, if you try to assign x to a number, no errors here. If you can see the red squiggly line, this is what the compile time error is. So early feedback you're getting, the more early you get it, the more easier your life is going to be as a developer. So this feedback is what we are looking from our TypeScript compiler. Okay, this is one way, and you can have another way of declaring and initializing a variable. You can say y equals to 20. And if you assign y to ABC, you'll still have an error. This is called something known as type inference. So your TypeScript compiler is smart enough to infer the type from the value that you have assigned without even saying its type explicitly. So you've assigned a number. So your TypeScript compiler has inferred your type from the value of the assignment, and it thought that okay, y is of type number, and if you try to assign something else, it's throwing an error. And you may know this if you are a C# developer. You have type inference in C#. Okay, but being explicit is a good idea. This is what I like it, even though you can omit this if you're assigning something, but explicit type declaration is a good idea. It is more readable and developer. It's like it shows your intention. You're trying to say that you're trying to declare a variable of type number. It's like putting forward your intentions clearly. Okay, now I want to output this y variable or something. Console log statement. As I said, all the features of JavaScript are available in TypeScript. Every JavaScript code that you know, every JavaScript concept that you know can be applied here without worrying about it. anything. Apart from that, we have few more new concepts such as number. This is specific to TypeScript. JavaScript doesn't have types, so this is extra feature of TypeScript. Okay, let's copy this code and go to our browser, open developer tools, go to console, try to paste this and execute this code. It will not execute. The reason is this code is TypeScript code and you're trying to execute this inside JavaScript compiler. This is JavaScript. This will accept only JavaScript and your browsers will understand only JavaScript, nothing else. So what's the solution for this? Here, this is the problem. We have written our code in TypeScript and this is your browser who can only understand JavaScript. We have introduced TypeScript for our own benefit because we are getting compile time type safety. But there is a gap. You need to bridge that. So you need to convert this TypeScript code back into JavaScript so that it can be executed on the browser. What's the point if your browser cannot understand the code? Because Angular application runs inside a browser, it doesn't make much sense if your code is not able to run on a browser. So for that, you have something known as TSC, TypeScript compiler, which will compile your code back into JavaScript. Probably compiling is a wrong word to use, and the correct term is transpilation because you're translating from one language to another. Rather than saying it's a compilation, let's call it transpilation. You're translating from one language to another language. Compilation is something you're taking the source code and you're converting it into something intermediate language, be it exe or .class file or something like that. But here, that's not actually what is happening. Your TypeScript code is being converted into JavaScript code. Okay, let's see how to do that. First thing, you need to install TypeScript compiler for that. Say npm install TypeScript -g. You know what is npm, and install command is to install it, and -g is to install it globally because I want this TypeScript compiler to be available throughout my machine, not just for this project. So I'm saying -g. So I already have this installed. I won't hit enter, but you should install it if you haven't already installed TypeScript. Once you have that, you can check the version like this. 2.6.2 is the current version that is installed on my machine. And now I can convert this file into JavaScript. Index.ts like this. TSC stands for TypeScript compiler. Index.ts is the source file. And this would be converted into JavaScript file. If you notice here, you have index.js. Copy this code and paste it in the browser. This is plain JavaScript, and you will not notice any difference or any errors while executing this code. So if you notice here that colon number is gone and everything, whatever specific to TypeScript is gone, now this is JavaScript code. This is what we will be doing. We'll write Angular code in TypeScript, and there would be transpiler, and the transpiler would convert it into JavaScript, and that JavaScript would be delivered to your browser. And this is, if you have clearly noticed this, this is only for development purpose, not in the production. TypeScript is only for developers and it is only for development time. At the time of development, TypeScript is used, not in production. What you have in production is JavaScript. The only reason that you're using TypeScript is to get compile time type safety. That's it. Other than that, there is no need to have TypeScript in your production environment. But even though this looks like a very small thing, but it's not actually. It is a really good thing, and TypeScript is really gaining popularity because of that. It's a great tool. It adds it adds types to your JavaScript, and you feel confident about your code. And you'll notice that if you write a couple of if you write a few applications, that's when you'll get to know how great a TypeScript is. It's open source project, even though Microsoft has started it. It's open source now. Okay, any questions so far? Let me know. Okay. So let's get into some concepts. We know what is TypeScript now, and we know how to transpile it. We know how to install TypeScript, how to use TSC, TypeScript compiler, and so on. So all these things, whatever we discuss today, is going to be a bedrock for the next upcoming sessions. So all the concepts what we discuss here, you will be using in Angular. So it's a very important session, I would say. Let's go ahead and close this index.js. We will never be modifying this index.js. And you can pretty much delete it because it would be automatically generated whenever you run TSC command. Okay, let's talk about the types. What are the types available? For there is no float, integer, something like that. You have number, you have string, you have boolean, and you have function, even though it goes back to again object. And then we have something like any. Okay, these are the few things that I can recall. As soon as I get something, I'll introduce them. But these are the things that I have in on top of my mind. Number. So if you want to save a floating point value or a decimal value or even a whole number, this helps. Something like this. And then string is something like this. In the same way, we have boolean. It can accept only true or false values. And you have a function. Definitely you can create a function and save it. Something like this. And then we have any. Any is interesting here. I'll say C, any. I can save a number in any. I can save a string in any, no errors. I can save a function. I can save a true or false values. I can save pretty much anything. This is what any means. It's like a object in C sharp, close to being an object. Like pretty much you can save anything inside an object, a number, a string, or a user defined variable or type, and so on. So these are the few types. One other thing is array. So you have array, you'll say array of number. It's generic. So what type of array you're trying to declare? If you try to save something, you say array.push a string, you'll have an error here because it's array of number and you're trying to push a string. And that's when TypeScript compiler is yelling at you. And the another way of declaring an array is something like this, which I prefer, like colon, like this. This one is close to at least Java or C sharp syntax, and this one is it's like a generic syntax. Anything is fine. I would rather go with this one. So this is a basic introduction of types. And as I said, when you are assigning a value, you don't need to specify what type of data that you are trying to save. You can again pretty much omit that, but being explicit is what I like. So I would say be more explicit and show your intentions. Okay. Let me remove these things. And next concept that we'll see is classes. So you have classes in TypeScript. You can create class and a method. And you can create an object pretty much similar to how you can create an object in JavaScript or in Java, like this. And the way you call the methods is also no different from Java or C sharp. You use new operator to create an object, and then you'll call a method using dot operator. And this code, I'll convert it into JavaScript by calling TSC and passing the name of the TypeScript file or the source file. Now, when you notice the index.js, the current version of JavaScript doesn't have classes. If you notice closely, it is converted into a constructor function. On top of that, you have methods on the prototype. So you don't need to come and read the code here. I'm just showing you because once we start developing a complex application, it becomes really impossible to understand the code that is being generated. Here, at least we have some idea like what's going on. Here, it's nothing but a class is generated, and this is ES5 output. ES6, ECMAScript 6, has classes. ES5, which most of the browsers support without any problem, doesn't have any classes. So this code will be able to run on most of the browsers today. If you try to generate an ES6 code, and probably you will be missing out a lot of browsers or a lot of audiences who will not be able to browse your application because the browser doesn't support the features. Anyway, so we will be converting our code into JavaScript version 5. Let's close this. There it is. So that's class. I'll go a little fast because we probably everybody of us have some background. We are not full-fledged JavaScript developer. Rather, we came from background of Java or C Sharp. So the concepts remain pretty much same. So let's go ahead a little bit faster here. And the constructor. So there can be only one constructor per class. There is no constructor overloading in TypeScript. And the constructor name will not be same as the class name. The way you do it in Java or C Sharp, it's not the case here. You will have a constructor keyword, and the constructor is the first function to execute when you create an object like this. Convert this into JavaScript code. File is converted. Now, if you want to run the JavaScript file, you can run it using a browser or node. Now, constructor is the first function and it will execute only once. The same way, the concept remains same for all the object-oriented programming language. Constructor is, for the most part, used for initialization logic. And if you want to have some properties on this class, you can have it something like this. No need of var keyword because it's a global variable. Local variables need var or let keyword, but your global variables don't need them, but you can have a const keyword here. Probably not. Excuse me. Okay. So you can have a const in local variable for local variables, not for global variables. Global variables don't need any keyword. It's this is how you initialize. And for the most part, I'll call them as properties because they are on the class. And if you want to access the value of x from inside a method, you have to be very explicit and say this dot x because it's an instance variable. So you need to append this dot. And if you have a background of Java, you won't feel this is like a crazy way to access a variable because that's how you do it in Java. Say this dot x. If it is local, you won't. You'll say let y equals to 20 and you'll just say y. It's not this dot y because it's not a instance property or a variable like that. Get rid of this. So this is another thing. And you have pretty much all the concepts such as inheritance. Here you can inherit from the parent class. I'll create one class, say base class. Assume that it has a property by the name z, and I'll inherit with the keyword extends base class. when you're extending it, you need to call super to call this super constructor of this class. So you may have learned already that if there is no constructor, there would be one default constructor provided by the compiler here. Even though you're not noticing a constructor here, there would be a constructor in the this class provided by the TypeScript compiler. So you need to say super in order to call the base class constructor, and that seems to be a mandatory thing here. And then you will do your whatever you want to construct in this class. And now, because this base class has a z property, I should still be able to access this dot z from my method inside this my class. That's inheritance. Even though we will not be using this that much unless you're going for an enterprise application. In this course, we won't use it, but it's a good idea that you know that inheritance is also there. Okay. The next concept we'll see is interfaces. So I'll clean these things up. Interface, and this interface can have some methods such as my method, something like this, like this. So this is a simple interface which have my method and my method too. We have discussed that interface is a contract. It's like it provides some specifications or it actually adds some constraints. So if your class wants to implement this interface, you need to say implements I my interface. I is a usual convention to specify that it's a interface. So whenever you need read the name of the file or something like that, you'll get to know that okay, it's an interface. And this convention is prevailing among the .NET developers, but this is almost non-existent among Java developers. Java doesn't follow this convention. It's up to you how you want to go. So if a .NET developer is writing Angular, he would rather put I in front of this interface name, and Java developer try to omit that. So it's up to you which one you want to do it. I would like to go with this I because this makes me understand that this is an interface without even opening the file, because the file name is going to be I my interface, because I'll put this interface inside a separate file. We'll talk about that, how to move things into a separate file. Anyway, there is an error because this I my interface has two methods and none of them are being implemented by your my class. My method is missing some methods. It's like the error message says that incorrectly implements the interface. So you're saying that these are your constraints, but this class is not adhering to those constraints. So you can say control dot, a shortcut to autocomplete the code, or you can implement yourself. Anything is fine. Control dot is the shortcut, or you can click on this bulb icon. This Visual Studio Code IDE is going to help you a lot. And that's why this is a very cool IDE. It's available for free, and it's out there to help you a lot. In Angular, when you're writing Angular application, this IDE will help you very, very like a lot of times. This is going to help you. Even though in Node.js, this doesn't come to our rescue, but here it's going to help you a lot because of TypeScript. It gives you a lot of code completion, a lot of suggestions, and so on. And even if you notice now, it has completed this code for you. Anyway, now let's remove this. And so you can implement more than one interface, even though you cannot extend more than one class. That is called multiple inheritance, and that multiple inheritance doesn't seem to be possible in TypeScript as well, but you can implement more than one interface, something like this. So we'll see this interface implementation. One important thing to note here is these interfaces are not available in JavaScript. They are just for development purpose. This code will be removed from the outcome. Let's go ahead and see what that means. As there is no equivalent concept available in JavaScript, this code is as good as useless for JavaScript. So it would be removed from the outcome completely. There is no interface, nothing here. The reason is JavaScript doesn't have interfaces. But it's a good idea that you follow the convention here in TypeScript because it's going to help you with some type checking or error checking. For instance, for some reason, when you're implementing it, you had a typo here. See, now you're getting error like that. So if you don't have this interface, and there is no way that you'll know the error. Okay, it still shows the error, but the error, it says duplicate identifier. Don't worry about that. That seems to be a wrong suggestion, but there is no way that you'll know it. But if you have an interface implementing, now you have an error message saying that it is incorrectly implementing the IMA interface. The reason is you have a typo. Just remove it and the error message should go away. Okay, for some reason, I'm noticing this error saying duplicate identifier. Not really sure where is it duplicate, but I would rather ignore that one because your code would compile without any problems. Okay, so that's about interfaces. Let's clean up. So far, the concept that we have learned is what is TypeScript, a little bit of history we have seen, like Microsoft has started and all those things. And then we have seen types. Then we have seen classes, interfaces. Then we have seen constructor, methods, and properties, nothing but your variables, actually global variables. And we have seen how to access them, how to create an object, how to access methods and properties. So these are the few things that we have seen, and few more things we'll see in the next 15 minutes. Okay. I'll create one math.ts file. Assume that I'm trying to create a simple calculator. I'll say math or say calculator. I'll have add function in it, add a comma b, and this returns a number. You can be more explicit and say what it returns like this. And you can be more explicit what it accepts like this. If you don't specify what it accepts any type. We have learned that there is something known as any. So this is how you write a method, and this is probably I feel it's a good way of writing a method in TypeScript. You are being more explicit about the type of the parameter that you're accepting, and you are more explicit about the type of the data that this function returns. If you try to return something else, you will have an error. If you're not returning, you have an error. If you're returning something, s- something which doesn't match, and still you have an error like this. Let me remove that. Okay, so I've created a class calculator here, and I want to access this in index.ts. How can I access it? Can I say calculator, new calculator, a calculator object I'm creating, and can I say calc.add 10, 20? Let's see whether this code will compile or not. So what I did is in the math.ts, I have my calculator class created and which has add function on it. If I want to call this add function from another file, and this is what I should do. Let's see if this code works. You have a compile time error. It says cannot find name calculator. It's not able to find the name calculator because by default it is private, whatever you write inside one file. So you need to export it. It's like you're making it public. Remember, we had in Node.js session module.exports. This is similar to this one. The only difference is this is one pattern and this is another pattern. And this pattern is common JS module system. So Node.js follows this module pattern, common JS module pattern, while this pattern is called ES6 module pattern. Now you may know that this is introduced in ES6. So this is one pattern and this is another pattern. So you say module.exports in one file and you'll say require in another file to import it. In ES6 module pattern, you say export here, and in the index.ts file, you're going to say import. You'll say import calculator from math. You don't need to specify the extension the same way we did in Node.js. So I'm exporting and importing. This is very easy than the Node.js. Anyhow, that's a pattern, but I feel this is more easier than writing module.exports and require and all those things. So here you can export more than one class. Assume that you have another class, my class 2. You can export even that one. If you want to import that class here, you would say my class 2. That is one way of saying that. Or you can even write another statement saying my class from the same file. Rather than having two lines of code for importing same stuff for stuff from the different stuff from same file, what I would say is I'll club both of them, and this is better than the having two lines of code, because you may be importing more than 5 or 6 elements from a file. So it's a good idea you club them like this. So this is very important, and we would be using this quite extensively. Excuse me. And what is this math is called? It is called a module, ES6 module. Every file is a module in JavaScript or in TypeScript. So again, the greatness of TypeScript is TypeScript didn't try to introduce new syntax. What it does is actually it copied all the syntaxes from the JavaScript because it wants to keep things as close as possible to JavaScript. So this module, even though we are writing it in TypeScript, it is actually ES6 module, JavaScript syntax. Okay, let me know if you have any questions on this. As I said, it's very important that you understand this module, and we'll have another module in Angular that is completely different. You should not get confused, but here module means a file. So you're exporting something from a module and you're importing something from this file. You have something known as export default. You want to export it by default, and here you can grab that without even having braces. You can say export calculator from math. So when you say that, the default exported element would be available here, no braces, and that is export default. By default, this element would be exported from the bunch of stuff. Okay, that's the module. And the next one we will see is decorators. So we have seen inheritance also. Inheritance actually extends the functionality of a class, or it adds. Decorators do the same thing, but again, they are really cool because you don't need to extend a class if you want to just extend a method or a class. So you want to do something that just for a property and just for a method, rather than going for inheritance, you would go with the decorators. Let's see what decorators are. You have decorators in Java, and you have something known as attributes in C#. So what I'm going to do here is I'll just comment this out. Okay, probably I didn't show you, but this code will compile. So when you say ts index.ts, there won't be any errors. There should not be any errors here. Here it is. The code is compiled. Now you have math.js and you have math.ts. Two JavaScript files. I'm sorry, math.js and index.js. Two files are created for you. Now go back to index.ts and we'll talk about the decorators. So I'll get rid of this code. I'll create one class, say my class. Now I want to decorate this class. Assume that I don't want my user to use this class, or I want to uh, mark it as a deprecated class. So how can you do that? You can create a decorator using function. Decorator is nothing but a function. So you will say deprecated, or just name it as deprecated, and say target of type function. And you'll just give a message saying console.log, this class is deprecated and removed from next version. Something like this. If you want to use this as a decorator, you will have at symbol and say deprecated. Something like this. So we have still okay, you are seeing some warning. Just ignore that. It's a warning. It's not an error. Just ignore that. We'll talk about that tomorrow. Say tsc index.ts. So the code is compiled with one error, even though I don't think that would create a problem. We'll try to get rid of that warning. But anyhow, when you execute your JavaScript file, this is what you get. This class is deprecated. So to achieve this, rather than having inheritance and all those things, what you have done is you have created a decorator, a deprecated decorator. Okay, now let's go ahead. And if you want to pass some parameters to this function, you'll wrap it inside another function. You'll say deprecated decorator. You'll accept something like an object or whatever parameters you want to, and you will wrap this inside. Get rid of this function. And if you know what is closure, this is nothing but a closure. So now you can pass some parameters to this decorator. Okay, something is wrong. No, it's not duplicate function. Okay, for some reason we are seeing these red squiggly lines. We should not be seeing, but this is how you create a decorator with which accepts some parameters. So you want to pass some properties, you can pretty much pass it. Okay, because the error was due to an empty object, but here it is how you create a decorator. So you have function decorators, you have property decorators, and you have even parameter decorators. We'll see them tomorrow. And whatever concepts we have discussed so far are going to be useful in upcoming sessions of Angular. So we are not yet done with TypeScript. We'll spend some more time tomorrow. Like we haven't discussed most of the decorators yet. That is one thing. And the second thing is we have this problem, this index.js, index.ts. It kind of creates confusion because if you want to modify this index.ts code, sometimes you may go and modify index.js. Or the problem is I don't want to have my index.js, which is output. I want this output to go in somewhere else, in some other folder or something like that. And I don't want to run this tsc index.ts every time I make a change. Every time I modify something, I'm going and running tsc index.ts. I want to automate that. I want to automate most of the settings. I don't want to go and give the name of the file. When I say tsc, it should compile all the TypeScript files and translate it into JavaScript. So all these things I want, and I'll show you how to do that tomorrow. Let me know if you have any questions, but these are some of the stuff that we have discussed. And if To summarize things, it's no rocket science. TypeScript, it's very simple language, and it is very close to Java or C Sharp.